Righty, we are moving on to new stuff. Very exciting. So this is inheritance. Again, we're going to hit this much more next semester. So we're going to kind of do a light version of inheritance here. There's a decent amount here in the chapter. Let me get the other book here. Um, Not too much though. So we'll probably go over all of this stuff here. And again, next semester we'll hit it a little deeper. We'll do an entire project on using inheritance, some of the cool things about it, and go from there. So I think we should be in pretty good shape. And then Thanksgiving week next week, don't come. You'll be lonely here. No one else will be around. The week after that, we're kind of picking up these last couple small topics. Recursion goes pretty quick. It's not a very big chapter here. Um, that's a big topic again for next semester. So we're going to kind of intro it. We'll look through a couple things. It won't be too bad. And then Python for data science is a pretty quick chapter. There's looks like a lot of different pieces here, but we're like, hey, here's a cool thing you can do. Here's a cool thing you can do. Here's a cool thing you can do. And then we also have to pick up this little bit of UML that we didn't get anywhere else because it's one of the things we're supposed to get to. It's just drawing a picture. It takes 5 minutes. It's pretty quick and easy. But if we all know how to draw the picture the same way, we all know how to read the pictures the same way, it makes it easier for us to discuss code here and designing code by drawing pictures of our code. Right? Um, Turns out if we all see the same thing, it's much easier to talk about than if I just talk. Right? I can show you something. You're like, oh, okay, now I can visualize it a little bit better here. So that works pretty well. These UML activity diagrams take another 5 minutes. They go pretty quick as we go. So we are about at the end of the class here. Again, on 12.8, I have no plans to do anything other than answer your questions. So show up and work on the project if you want. This is sort of my soft goal for everyone to be done by 12.8 here so that you can do other things, focus on other stuff for your final exam week here, and then you'll just have your turn to present. You'll get up, run it, show us you can play the game, save it, load the game. It takes maybe 5 minutes if you want to talk a lot. I might have a question or two about your code. I got to get you a rubric, though, for the final project. Here, that's the thing I was missing. Let me go add that in here. I got most of the projects scored. I think I still need to do project 3 in the midterm. I'll definitely have those in over Thanksgiving break. I can get all that in so you know where you are here. Rubric, there we go, for final project. All right, I will use this one for grading. So first one here. Nope, that was the wrong button. That's fine. Variable number of players can play. So how many people are going to play, and you play with that number of players, right? Works out pretty well here. We'll have classes, player and property, private attributes, public functions, right? Good object-oriented programming design here. We're going to reuse classes here. Technically, you don't need to use classes, but if we want to get in the habit of using them, it's good object-oriented programming to do it. And that's what we're going to run into in the rest of the world. So we want to be better at writing code than Mr. Matt from Stand Up Maths, who writes terrible Python code. But it's okay. He's a mathematician. We can just make fun of him for it. Okay. And then we have points for the game actually works here. So like the gameplay itself, you can buy properties, you can sell, like these sorts of things happen. You move around the board, you roll the dice, the doubles, all those pieces of the game actually working right here for that. And then the last bit here is saving and loading. Right. 10 more points. So that should be the 40 points for the final project here. If these things work, you should feel pretty confident you get the points. Again, start early, do small little bits here, right? This idea of functional decomposition, my favorite technical term, throw it out at your Thanksgiving party. People look at you like you're crazy here. Start with something small and solve the small thing. And then do the next small thing, and do the next small thing, and do the next small thing. You don't have to do everything all at once here. And you want working code so that you can actually test it out here, right? Hey, okay, the game starts and says that you want to play with 2 to 8 players, but I only make 2 players. That's fine. That's a good start. Later, I can go add in variable numbers of players. Or, hey, you landed on this property, you don't want to buy it. You hit yes, but nothing happens. I don't know how to buy and how do you buy property yet? You don't have to solve that right away, right? The menu, it says you're going to. We've got a place for it. We just haven't done it yet, right? What happens if I land on someone else's property? How do I take my money away and give money to them? I don't know yet. That's fine. You landed on someone's property, right? We're going to do this in little steps here, and this is a good habit because this is how we write code in the real world. We want to tackle little bits at a time, little bits at a time, little bits at a time here, and make sure those little bits work, right? I'm not asking for unit tests. there's not really a whole lot of anything happening here. We're really only using the classes to store their attributes, right? And then we can read and write them from a file with their list of attributes. It's going to work out relatively well for us here. Um, all the game logic here ideally would go in some sort of game class because Monopoly is so fun, we could turn it into a calculator game for those calculators that run Python, right? And it might not have the same kind of inputs and outputs, or maybe turn into a web application, or sure, but it's okay. We don't need to have other classes that do all the other cool stuff if you don't want to right now. It's not the end of the world. Um, and then here's the list of the Monopoly rents if you wanted that one as well. So you can build out the official ones. If you want to change them, go for it. You want to have your own favorite flavor of Monopoly, go for it. If you want to make up some numbers, that's probably fine. Um, it's not going to be the end of the world here. Uh, but it'll look much more familiar if you actually use the official properties, is all. We're not doing houses and hotels. But, right. Questions, thoughts on this one? Feeling pretty good? At least know how to get started? Yeah. Um, no, I mean it'd be nice to, but we're not doing houses and hotels. We don't have the sets here. Yeah, so usually the rent doubles if you own all of the set, but don't worry about that too much. Yeah, this is just a stripped down basic version here. Uh, yeah. All right, awesome. So let's get into inheritance here. Let me fire up PyCharm. Now, inheritance is a fundamental of object-oriented programming. It lets us take a class that exists and make a special version of it, right? Something that is of the parent class, but does something unique and special here. So we're somewhat familiar with inheritance through biology. The way that we classify things, you have the kingdom, the phylum, the class, the order, the family, the genus, and the species. I don't know why that's still in my head, but it's been in my head ever since I took high school biology, and it's just fun to recite that for some reason. We're good at learning patterns and things like that. So, right, if you're a mammal, there are attributes of mammal that all mammals share in common, but dogs and cats aren't the same kind of mammal, right? They have their own unique set of attributes that make them unique and distinct, but they all share the same attributes of mammal, right? They give live birth, and I forget other attributes of mammal. Didn't pay that much attention to biology to remember it that many years later here, but we know they share attributes. So the idea with our code is we're going to write classes that are so wonderful and fantastic and amazing that we don't want to have to reinvent the wheel. But if I want a special version of that class, I can inherit from a class and just change the pieces I want without having to reinvent the wheel. Right? So we went through and we made, hey, this is an item class, right? It has a name, it has a quantity, it has a price here. That's fantastic. What if I wanted to have a taxable item? I don't want to have to reinvent the wheel. I don't want to have to redo all of this stuff to have name and quantity and price here. I just want to be able to add the tax piece because some items in Michigan are taxable and some are not, thanks to our interesting tax law. Sure, right? So let's do that. So we can add a class here. Um, can I just add it to project 3 or do you want like another week module or something? That's okay? Okay, so I'll add it in here. So I'm going to add another file because I like modules. Again, you can put them in the same one. I just like separate ones. Makes me happy here. This is a taxable item. And then taxable item needs to from item import item. When I create this class here, I'm going to say, hey, this is a taxable item. And then in parentheses, I'm going to say it is an item. So this is the class you inherit from. Remember when we did these test cases, it says, hey, it's a test case. This was using inheritance. We just didn't need to really know a whole lot of detail. So this is a test case. It can do all the things test case can. And this is a special version of it because it does this specific test, right? All the other things behind the scenes that make it runnable and give you the green exit or the green checks and the red X's, that all comes from test case here, right? It just knows, hey, this is a special test, right? So taxable item is an item. So if that's all we have here, then define init. Now, if my item class has an init that needs a name, a quantity, and a unit price, I need to at least go get name, quantity, and unit price because I need a way to set those for the class I'm inheriting from, right? So let's actually, I think, is it going to suggest it for us here? Hang on. Init, here we go. We want this super class call. It's a keyword here. Let's see, I think we get more actions here. No, it's not going to give us. Oh, yeah, there we go. So we're going to add the superclass call here. It says, hey, your superclass. So we use parent class and child class. There's superclass and subclass. There's also base class and derived class. because programmers love giving multiple names to the same thing. That's not confusing at all for anybody here. But super is the keyword that we use to indicate your superclass or your parent class. I prefer parent and child, but super is the technical term we use in Python here. So we're saying, hey, if you give me a name, quantity, and price, I'll hand that to my superclasses init function here so that the item class can go set name, quantity, and price here. Right, so you can make a taxable item, name, quantity, and price. Now, what's special about taxable item, though, we probably need to know the tax, right? So we're going to give it a tax rate, okay? The first thing we're going to do is ask our superclass, hey, go set these things here. Then we can go set our own tax rate. So self dot, we probably are going to have a function for it, right, for set tax rate, but that's probably changeable, right? Politicians can change the rules anytime they want here. Um, so we're going to set the tax rate given the tax rate. And then in our set tax rate function, well, let's do some sanity checking here. So if I ask you what the tax rate is in Michigan, what's the sales tax? What are you going to tell me? 6%. Okay. So given a tax rate. Now, if you were to tell me 6%, what value would you type into set tax rate? Would you give me the number 6 or would you give me 0.06? So you're a good person. Most people aren't math friendly sort of people here. For some reason, everyone grows up hating math, probably because of how we teach it. I don't understand, but that's okay. So when you say 6%, they're just going to give you 6. Because obviously 6 means 6%, but 6 would be 600%. We don't want to pay a 600% tax, right? So we can check. We can say, hey, if my tax rate is greater than 1, let's take tax rate divided by 100. They probably just did a bad thing here and gave me 6 instead of 0.06, right? So let's fix it for them, right? Let's make this friendly, right? If they didn't, then that's fine. I can just set my tax rate now. So self.tax rate is the tax rate, right? It's probably fine. And maybe we want to check, make sure it's not negative, right? I don't think we have a negative tax on anything. We don't give people money for buying stuff, usually, right? That sort of thing. So this one's probably fine as a sanity check here. And we also have a get tax rate, and we return self.tax rate, right? So we have our get, we have our set. Now, what we want to do, if you get the total price here, is we want to do something different. Because we're going to tax this item here, when I get total price, I want to do a different thing. So I am an item. I do all the things item does here. So in my main class here, if we go and from taxable item, import taxable item, here I can make a taxable item. Right? I can just say, hey, here's some taxable item equals a taxable item given. Now, is it prepared foods are taxable, but not fresh foods or other sorts of products here? So how about we just buy like paper plates? Plates here. That's taxable. We buy them in like in 100 pack here, and they're like, I don't know, 5 cents a plate, something like that. And a 6% tax here. I know I'm going to divide by 100, but okay, let's be better. Let's give it 0.06 here. Right. We'll do the right thing so we don't have to do the division. Right. So I've got taxable item now. Now, taxable item dot, see, I get all of the functions here, and you notice PyCharm is telling me, hey, this one came from item, this one came from item, this one came from item, this one came from taxable item. Right? So it's indicating in my IDE where it's coming from. This is just a visual hint. Because we are an item, we've inherited from item. The technical word here is a relationship. So it is a type of its parent class. So taxable item is an item. Right? You can do all the things item can do. Here you get all the same public functions because we've inherited. All those public functions are accessible, and then the special versions. Now the problem is we wanted to change what the get total price does because I don't want it to forget to include the tax. So what we're going to do is we're going to use this little at override keyword here, override here. At override is an annotation. It's just telling Python, hey, I want to do something different than my parent class does. Here. You don't need to put the symbol in, but it gives you checking to make sure you did it the right way. So I can then define a function like get total price here. And it knows, hey, I'm overriding the get total price from my parent class. And I'm going to return my self.getQuantity times the self.get unit price times 1 plus the tax rate. right? Because we know we've divided by this here. So in parentheses, 1 plus the self.tax rate. I'm sorry? So we are in our class, so we have direct access to it. You could use the public function, but we're in the taxable item, so you can just access your private attributes here. Uh, right, self dot quantity. You can technically get the quantity here from your parent class. It's, you know, this is usually fine because we are an item. You can use your private attributes here as well, or you can use the public functions. Um, either one's really okay because we are an item. We're like pretending we're an item class here. Um, either way is okay. Uh, right. So we're just going to do that calculation and return the value. Okay. The other option we can do here is I can say I want my super dot get total price times 1 plus parentheses 1 plus my self dot tax rate. Okay. So if your parent class is doing something that we don't want to repeat here, we can just ask it, do the superclass version here, then go do something special. So that's actually probably preferred here. So we can return this value here. Sorry, that's the wrong comment symbol. I was just doing C++ an hour ago, and I'm really confused. I was trying to write Python code in my C++ class, and they were really confused to me. Um, so you can get your superclasses version here this way. Say, hey, superclass, go do this thing for me, please. Right? I don't want to reinvent the wheel, but I want to customize it. So now what we get to do here, I can go get total price, and it says, hey, this is the one coming from taxable item here. Right? If we just print it here, it should be what, $5 plus 6%, so $5.30. Does that sound right? And we'll just check it here. We should probably do a unit test, but we're just going to eyeball it here. Uh-oh. That one fractional penny. You're mad at McDonald's taking your 2 pennies away when they round here. We should really be mad at the zillionth of a penny being added into our prices, right? That's really going to add up real fast. No, okay. Um, someone posted a thing online, and I shouldn't engage with people online. I should know better here. They were all upset about this penny rounding, and they're like, "Hey, Kroger is stealing money from us." But it turned out Kroger gave them 2 extra pennies, but it was labeled penny rounding. And they went on this big rant about how Kroger's an evil corporation stealing 2 pennies from them, but they just didn't read their receipt correctly to realize they got 2 extra pennies back. They're like, everyone boycott Kroger, they're evil. They took my pennies. But they gave them the pennies. And you're like, this is the state of math education in the United States. People don't understand how to read a receipt. Because that's a story problem. And story problem math is hard math. I don't know. I'm sorry. I kind of like math, but probably because I was good at it. That I'm sure has skewed my perception of math here. All right, cool. So taxable item, get total price. The other crazy thing we get to do now with inheritance is a technical term called polymorphism. It's a really fun term here. It means we can treat an object as its parent class. So I can take a taxable item and use it anywhere I would have used item because it is an item. It just happens to be a special kind of item here. So if I were to write my own function here, oh, I'm sorry, let's just do this here, right? It should just work. So I can take my shopping cart and let's go add this to my shopping cart. So we'll add our taxable item. So we'll take cart.add item. It's expecting an item, but we're going to add a taxable item here, right? Let's go see if it runs. So what do we want to buy? Bananas, 7 bananas, 30 cents a banana here, and we'll quit. Shopping cart has no idea that taxable item exists, right? The only thing it knows is that I'm expecting an item, and item should have a get total price function, right? What inheritance lets us do is make that special version here, and while the program is running, if you give it a special version that has an overridden function for get total price, it'll use the overridden version dynamically, which is actually really cool to think about how that all happens behind the scenes here. Because it's expecting an item, it should probably go to the item class get total price, but because we've overridden it, it goes to the taxable item get total price function, which is really cool that this polymorphic behavior happens. So we can get the taxable price out here, and because my shopping cart says, hey, I'm going to get the total price here, it properly gets the total price that includes the tax from a taxable item when it thinks it's just a bunch of items. It's kind of like magic. It's really cool. Um, And I'm really glad people who write compilers and interpreters and things like that are smart and study that kind of stuff here. I'd never want to touch that. I just want it to work. And I like that the magic works and it makes me happy. Right. But that's one of the cool things. You can take a whole class on compiler design and learn how this sort of stuff kind of happens behind the scenes and where all that magic is. It's neat. But we didn't have to change shopping cart to be able to use taxable items. That's one of the benefits of inheritance and polymorphism. We can make special versions of classes, change their behavior where we need to, and it still works in place without having to change a single other line of code. It's beautiful. Okay. The next thing we could do if we wanted to is we could add like a perishable item, right? And probably with perishable items, what we're going to do is say, hey, if it's the day before it expires, let's mark it half off so we can sell it. Because if we don't sell it by tomorrow, the law says I can't sell it anymore and I'm going to lose all the money. So obviously, let's get some of our money back, right, and sell some old produce. It's perishable. It's not actually bad after that date here, but that's okay. That's a whole other story. Yeah.
How long do Banans last before they perish?
Did I spell it wrong? Oh, no. Uh, it's a good question. Not long, not long. But if you wrap up the stem, it lasts longer or something like that, right?
But
Isn't that the trick? You wrap the stems and they stay good longer? Or do they go bad faster? One of the two.
it's like a bill or something like that. Not true.
No, it is. We actually did it with my kids here. Yeah, keeps them fresh longer by wrapping the stem. It slows the ripening process. Somehow from the stem, it's something is triggering the ripening, or I think that's probably where the air can get in from the stem is I think why that happens, right? The rest of the banana is pretty well sealed.
There's a show in the UK called QI, it's short for quite interesting, and they bring comedians on, and like even the host is a comedian, and they'll ask these kind of questions. Each series or season is based on a letter of the alphabet, and each show is like a different thing. They'll get the comedians to answer questions like this, like, oh, so like what could you do to like the stem of a banana to make it last longer? And usually they'll ask that question, and they'll want comedians to give that answer, and it's because it's wrong.
Yeah, yeah.
And so they're trying to get them to say so they essentially can make fun of the comedian, and then they'll say, no, actually this is wrong, and the right answer is this, or like when people tap the top of their can to get the bubbles to go down, that doesn't actually do anything.
I thought it did.
You tap the
It's
side of
been
the
a
can,
lie. It's been a lie my whole life.
yeah,
So fun stuff, fun facts.
just a thing you'd see on that
Yep.
show.
Um, so inheritance lets us do this really cool stuff because we get polymorphic behavior, which is really fun. So it's a derived class here. You can access your base class attributes here, right? So um, they're saying you can still get at your parent class attributes here, which is makes sense, right? You are that type, you can go get at them here. Um, you get this hierarchy, right? This is like the kingdom phylum class. You can inherit from and inherit from and inherit from and inherit from and inherit from as many times as you want, essentially. I think there's probably a limit somewhere, but it's got to be in the thousands. And if you've got that much inheritance, I don't know how to help you. Something else has gone wrong here. But you can do all that here. So that gives you a lot of fun with inheritance. And then we can override that behavior. And you don't need the at override keyword here. You don't need the annotation, but what it lets you do is make sure you didn't screw it up here. So because I like to make typos all the time here, if I say I want to override something and then I don't because I've typoed it here, it's warning me missing the method to override. So it's going to give you a clue that you did it wrong, probably a typo here, right? That you didn't actually, you wanted to override something, but you didn't. So this is just a nice helpful thing to have in here, not required, just like the type hints that say, hey, this should be an item. It's just a helpful thing to have. We're adding in more of these tools to let us get some checking while we're programming, right? Which is nice. Um, so we're just saying, hey, it's supposed to do this. It'll do it automatically. But if you typo it, bad stuff will happen because it doesn't find the match here. It doesn't actually change it if you have total price instead of total price, right? It's not that magical here. So you can override them here. Um, the is a relationship, again, we are the type of parent class here, right? But a mother class has children, but children are not a mother, should not be a mother. I guess that's another, go take a sociology class, uh, right? This is a has a. We have a list of children. We don't is a children or is a mother, right? So a lot of times after we teach inheritance, everyone wants to use inheritance for everything. But that's wrong. It's just one tool for one particular kind of solution that we need here. You can use it, right? So if it is a type of its parent class, it makes sense here, right? So some people, when we give them Monopoly games, like, oh, a property is a type of board because we want inheritance, but it's really not, right? Board has a list of properties. The properties aren't the board, or the board isn't a property, right? So players have properties. They're not a type of property. So don't use it like a hammer for everything here, but for some solutions, it makes sense to use inheritance. Um, and then the last thing, this is specific to Python. Not most languages don't do this. Yeah, I'm pretty sure we can say most here. You can only inherit from a single class. Python says no. You can inherit from as many classes as you want here. So sure, your vampire bat can be a winged animal and a mammal. Sure, you can inherit from both of them. Winged animals let you flap wings, mammals let you give birth. And if you're a vampire bat that is both, then sure, you've inherited from both. Now, the reason why this gets really messy is in the programming language itself, it usually says, hey, does this function exist in my class? If it doesn't exist, does it exist in my parent class? If it doesn't exist there, does it exist in the parent's parent class? And like works its way up that hierarchy. If both of our parent classes have a function like make noise, right? Mammals make noise, winged animals probably make noise. How is it going to know which one to do? It just does the first one it finds. So the first one you inherit from in the list, it'll do that version, and you might not want it to. So it gets to be a little confusing. So usually multiple inheritance is frowned upon, and we'll try and avoid it here. Um, but you technically can, right? You're allowed to do a lot of things that are probably a bad idea. So same thing in Python here. You're allowed to do a lot of things that are just bad ideas. So we just won't. Okay. Um, the mix-in thing, don't worry about it. We'll talk more about that next semester. That sort of topic. But sure, a jet is a transport mode and a flying. Makes it, yeah, sure. So you can do some fun things. And then testing code, they now finally get to unit tests here because unit test extends test, or derives from the test case class, right? It is a test case. That's why we get these self.assert equal functions. We didn't write the assert equal function. That came from the test case class here. We had access to it because we were one of those things. So I can use my assert equals here. Now, the reason why we had to say super get total price is because I'm overriding, right? If I just said get total price, or like self.get total price, it would do my version here, which would do my version, which would do my version, which would do my version, right? If I wanted the superclasses version that I'm trying to override, I have to ask for the superclasses version here. So that's why with the unit test, we could just say self.assert equal. We didn't write our own assert equals. We didn't override that behavior. So because I am an instance of test case, I get all the functions from test case, right? So self dot, we can see, hey, these all came from test case or test item, right? Test case. We can do a bunch of things here that all came from that parent class. You can count them, I guess. Sure, right? You can default it. Sure, you can do cleanups. I don't know. I don't know what these things are. I didn't write them, right? But they came from the class I inherited from, right? Which is nice. Excuse me. All right, I think that's probably pretty good. Yeah, those are all the different asserts here. Um, Look at that. You can run tests. That's probably enough for inheritance. We'll get to this again next semester. We'll do a whole project on inheritance, using inheritance, and we'll do multiple. This one inherits from this one, which inherits from this one here. We'll work our way all up and down the chain here. Um, and then we'll play a little thing that uses the inheritance. It's a lot of fun. Okay. So again, we'll come back to this one. We'll get deeper next time around here. We just want to introduce the topic so you're familiar with it here. Hopefully, it makes a little bit more sense. We got 2 chapters left. Not next week, Thanksgiving week. Take a week off here. Feel free to do nothing for this class, or if you want to work ahead on the final project, go for it. It's up to you. You can manage your time, I hope, here. But at least take Thanksgiving Day off. Right? Go have some turkey or tofu turkey if that's your jam here. It's gotten much better. It used to be a lot worse a couple years ago, but lately the tofurkey's halfway decent. My daughter and I like that one. Um, and sounds good. I don't think we've got anything else today. We'll get off a little early. Um, The lab next week will do a quick little inheritance thing, along with recursion and then a Python. So it'll be like three small things we'll do in the lab. Um, it'll go pretty quick. They're like 10-minute tasks here. So one of my favorite things is matplotlib here.
Love that.
It lets you draw graphs, and it uses someone else's library to do it. All we have to do is tell it, hey, what's your x's and what's your y's? And you can do a bunch of other cool things here, and it will draw a pretty picture for you. So we can finally communicate something with pictures rather than having text on a black box screen, which is pretty terrible, but is not loading for me right now. So we'll get to it in 2 weeks. Okay? Oh, there it goes. Yeah, let's see. Does it give us a little scatter plot? Yeah, they're so good. It's so good. All right. That's all I got.
So we don't have class next Monday. It's the following Monday after that.
Yeah, yeah. Don't come next week.
Okay.
The all classes should be off. I think I
Yeah.
followed the schedule right. I think the
Yeah.
campus is still open if you want to come to the library at some point. I don't think we close till actual Thanksgiving Day. Um, schedule. I think it's on here, right? Fall. Yeah, recess starts the 22nd. Saturday goes through Sunday the 30th. When is campus actually open though? Campus hours. Oh shoot, it's on here somewhere, right? Standard building hours, campus break building status page, TBD. All right, that's not very helpful.
Might be updated.
Okay, yeah, but yeah, we'll look it up here and see. Library. I think it probably knows, right? They're pretty good about posting their hours for Thanksgiving. More hours. Next week here. Okay, so Monday, Tuesday, it looks like they're closing Wednesday for the holiday, and then they open back up Sunday the 30th.
Okay.
So at least the library will be open Monday, Tuesday next week if you want a place to hang out. Probably the UC is similar hours, but I don't know for sure.